buildings. And this will be also the case in 2020 in France. Then with the kind of product which I am showing here, we are able to match this kind of regulation and to match this kind of demand. And, even with the product that we are developing for customized solutions, I would say, we are also looking into developing solutions that will bring the most in terms of thermal performances. Okay. The second element which is important in the facade, and I think Lars has been talking about it also earlier this morning, is the solar control. And it is even more important in this region. So of course the solar control, one of the most well-known way to manage it is through the glass. And I will not go into this one because it's not my expertise, but the second way it can be managed is through what we call a sun shading device, brise soleil. And on top of being an important element of architecture, because the architect, they can design it in the way they want. It is also a very efficient way to manage to control the sun energy. And there have been some simulation. Of course, if you put some brise soleil, you might be losing some energy in winter and some free energy in winter. But it is way below that than the energy you can gain in winter by protecting the facade from the solar infiltrations. In terms of brise soleil, there is one rule which is quite simple in terms of efficiency. It's you have to put it outside and at a reasonable distance of the facade. If you want it to be more efficient, if you put it inside, and if you put it close to the facade, then you will lose a lot of benefits from this kind of brise soleil. I think the best position is this one, having 80 centimeters from the facade will give the best control of the solar radiation that are transmitted into the building. This was also a study that was done, which is going in the same direction, because not everything is about energy and energy saving. It's also about the comfort of the users, and you can see that when we have something which is not very efficient in terms of insulation of the solar radiation, then the discomfort is increasing. And in office, so when you are talking about discomfort, we are also talking about lesser productivity, I would say. The third element, which is important in the facade, are the ventilations. And as you know, most of the time, the ventilation you are using window integrated in the facades. And I would say that most of the time, because of cost efficiency, I would say, we are using this kind of window, which are the top windows, and also because they are easy to integrate in the facade. But they are probably not the best in terms of how can I say, efficiency to provide a natural ventilation, and it would be much better to provide either tilt inside, or even better to provide parallel out openings windows, which will be in terms of ventilation much more efficient. So in fact, as I said, the technology product-wise is fully available to build and to install a very efficient facade. I think the biggest challenge that we have today is how we can manage all these products together in such a way that we can optimize the user comfort while we are minimizing the energy consumption. And this is something which is quite complicated. It's complicated, first of all, because it means that all the system that we are going in such kind of facade will have to be motorized. So, and as you know, motorization in our industry is something which is growing day by day. But it is complicated also because it will request the development of what we call an expert system to be able to analyze at every time of the day or of the night, to analyze a different parameter, the outside parameter, the inside parameter, and the status of the different elements in the facade, in order to get the maximum out of it. We are going to present this year there will be an exhibition next week in Paris, which is called Batimat, and Technal is always present in this exhibition, which occurs every second year. And we are going to present this prototype of facade that has been developed in our company. And we have also developed the expert system, which is going around, and then we will show some simulation how the facade can react, how the brise soleil can orient it, how the ventilation can open, how the lighting can be also inside can be also automatically controlled regarding what is the lighting which is being from outside, etc., etc. So, and this is probably the way forward for all these facades. Yes, there are the products, but behind the product, we will need to have expert system to be able to manage the complexity of the analysis of the integration of all the different parameters. And I just could not avoid to talk a little bit about smart houses. As it has been said before, I've been in this business for a little bit more than 35 years. And I've been hearing about domotic, smart system, smart technology for maybe as long as I have been in this business, and so far not much has come. But it looks like with the development of the tablets, with the development of the smartphone, and all this kind of new technology, this is also going to happen into our industry, into the building construction. And if you see at the at the projection of the increase of this market in Europe and United States, it is quite tremendous. So I think it's a very promising market for tomorrow. And this is why also at the beginning of the presentation I was telling that we are also a system supplier, have to move from product supplier to solution provider. And this will be this system, and most of them are already available also. This system can help you to ventilate your house, to control the solar ray, to link with lots of different captures, and to integrate active security and access control. Of course, all of things is available, and we can bet that tomorrow you will be able to watch your TV on your facade, or read your email on your window. Just as a small conclusion to this part of the presentation, we did some simulation on some building that we have been doing. The first one on the left is a building which has been done in Qatar, in the Catalum factory, and with a normal facade, I would say a simple facade. You know, the energy consumption is about 85 kilowatt-hour per square meter and per year. With the if you add to this facade some kind of brise soleil, then the consumption will be only 65. And if you put some photovoltaic on the top, so you will not have only a passive building, but you will also have a positive and contributive building to energy demand. And the second one is a simulation I did in Bahrain, where we had this kind of apartment building to do. And I think the project owner wanted a simple, cost-effective window, so non-thermally broken window. And then we tried to convince him that by using not very high, but not very sophisticated, but at least good thermally broken window, he could gain a lot. And after doing the simulation, you can find that just changing non-thermal frame with the thermal frame, you can gain about 7% of energy. And this building, I don't remember, it was a 20-story, and the amount of energy we could save in this building throughout the year was something like 140,000 kilowatt hour. And when you know that to produce 600 kilowatt hour, you need a barrel of oil, we imagine 140,000 kilowatt hour, you could save something like 240 barrels of oil per year only on this building. So I don't understand why these countries are not more tough on the regulation, because every barrel of oil they are wasting to produce energy, which is wasted, they could sell it today, unfortunately, only at $50 or $55 per barrel. But when I did the simulation, it was something like 100 or 110. And calculating the payback with this kind of information is very useful, because payback of the additional cost of a thermally broken profile would be only 2 to 3 years. Okay, after that, it's all gain. So we have several other challenges in our industry. We are lucky to have aluminum, which is a tremendous material when it comes to recycling. In our company, we think aluminum as a bank of energy, because all the energy which has been embedded in the aluminum, in the material itself, when produced, will be reusable, because to recycle aluminum, we need only 5% of this energy. But we have some other challenge around the aluminum. We have polyamide strip. My friend Alex is here, and I know that they are working hard also to provide material which will be more and more recyclable. But we still have the gasket. EPDM is not very user-friendly when it comes to recyclability, but I know they are working also. And in our system, we are also in systems we are using also zinc casted aluminum. We are using also steel. We are using also many other materials which are not very easy to recycle. But our dream in SAPA is that sooner or later we will be able to provide 100% recyclable aluminum window. Acoustic efficient facade. I just wanted maybe to show you a small video. This is a product that is going to be presented in Batimat in Paris also next week. If you can just show it.
Le bruit est de plus en plus présent dans notre vie quotidienne et arrive souvent en tête des sources de nuisance. Tecnal présentera cette année, à l'occasion du salon Batimat, un concept innovant de châssis coulissant avec un système de réduction de bruit permettant d'ouvrir sa fenêtre sans être gêné par les nuisances sonores extérieures. Ce résultat, qui peut paraître incroyable, est obtenu grâce à la combinaison de deux technologies. La première technologie, dite passive, consiste à créer des parois latérales avec un absorbant acoustique le long de l'ouverture afin d'atténuer, à la manière d'un silencieux, les sons qui arrivent dans les moyennes et hautes fréquences. La seconde technologie, dite active, consiste à capter cette onde, à l'analyser et à générer un son inverse qui correspond à ces mêmes vagues, mais avec des creux à la place des sommets et vice-versa. En envoyant cette onde sur l'onde incidente, les creux et les sommets se compensent et on obtient une atténuation marquée du bruit dans les basses fréquences. D'un point de vue pratique, de petits micros sont intégrés dans le profil émontant du cadre de la fenêtre et des haut-parleurs sont disposés dans l'une des parois latérales de l'isolation passive, l'ensemble étant piloté par un microprocesseur de signal numérique. Ce système permet de traiter l'ensemble du spectre de fréquences et d'obtenir une atténuation jusqu'à 25 dB, soit une réduction de bruit de plus de 300 fois. Cela correspond au passage de l'ambiance d'une rue animée à celle d'un bureau tranquille. Mais écoutons plutôt les résultats dans les faits. Sur cette fenêtre, le système de réduction de bruit a été implémenté sur le ventail de gauche et a été optimisé pour une dimension d'ouverture de 10 cm. Le ventail de droite est lui classique. À l'intérieur de ce caisson, nous allons générer différents types de bruit à un niveau d'environ 80 décibels, puis nous écouterons le résultat, d'abord en ouvrant le ventail de droite, puis en ouvrant le ventail de gauche. Les niveaux de bruit extérieur et intérieur seront visualisés grâce aux 2 vues-mètres de cet écran d'affichage. Le premier bruit est un bruit de terrasse de café. Écoutons d'abord avec le ventail de droite, ouvert de 10 cm. Écoutons maintenant avec le ventail de gauche, équipé du système de réduction de bruit, ouvert de 10 cm. Le deuxième bruit que nous allons écouter est celui d'un avion. Donc d'abord, ventail de droite ouvert. Maintenant, ventail de gauche ouvert. Le dernier bruit est un bruit de trafic routier. Donc déjà, ventail de droite ouvert. Maintenant, écoute avec le ventail de gauche.
Okay, so was just an example to show you also what we are doing in terms of R&D. Energy consumption is something, but it's not everything. We are also working in such domain as the acoustic. Thank you very much.
Thank you, Jean. The next speaker for the day is from Chile, and we have a change in the speaker. We have Mr. Armin Franke from Chile, who's going to give you a presentation on architectural concept and realization of the King Abdullah Center for the World Culture Center in Bahrain.
Good morning, ladies and gentlemen. It's my pleasure to talk to you about an innovative